Hello and welcome to the video on finding the volume of composite figures. In this video, we're going to show you two examples on how to find the volume for the relearning and the reassessment. In this picture here, we have a hollowed out center in the middle right here. This hollowed out center is what we're looking at, not getting the area from. It's all the outside area. So if we take a look at that, we have a rectangular prism. And because they're one inside the other, we're going to eventually subtract the two areas out to find the value inside. So the volume of a rectangular prism is the area of the base times the height. So if we look at this area of the base in here, we look at this area, we have it right here. You can see that it is a square. So when we look at that, we can see that the area of that base is going to be 30 times 30. And then the height right here, is what we're looking at. So basically we're saying that we have a section on the bottom right here, the area of the base. We have in here 900 centimeters cubed. 900 centimeters cubed. So if you were to think about that as an office building, it would be an office building. The first floor would have 900 offices on it. Each identical, each the same height, width, and length. And you would have 900 of those. Now we're talking centimeters here, so it's really not an office building. But in the same regards, that's kind of what we're thinking about in here. So how many levels in this office building do we have? Well, we have 300 of them. We have 300 layers that have 900 apiece. So the volume is the area of the base. It should be area of the base. It's the area of the base, which is 900 times the height, which is 300. And that puts us at 270,000 cubic centimeters. So in this office building, if we were to think about it as an office building, on the first floor would be 900 offices, second level 900 offices, second, third level, all the way up to 300 of these levels. So now it's just a way of using our imagination to be able to find out how these would work. But as you can see, we were talking about this. You have the center part right here, the center part, and the center part is empty. So really, in the middle of these office departments, we have an elevator, a round elevator, which is super cool. But that shape, if we were to put it in mathematical terms, that shape of that center is a cylinder. And if you were to think about a cylinder, it would be like a toilet paper hole, toilet paper ring, or a paper towel, the cardboard part that's in the middle. Or you take a piece of paper and you circular and you shout through it. Now this is also right here, 300 centimeters tall. So we're going to still look at the same way. The volume equals the area of the base times the height. But the base that we have down here is a circle. So we have in here, we need to find the area of the base. And the area of the base for this figure is pi r squared times the height. The area of the base is pi r squared. I was getting a little ahead of myself. So we're going to look at that and we're going to see how many squares fit in here. They don't fit evenly. It's going to be a decimal value. So pi r, and we see up here the r is given to us is 3 squared. So we have 3 times 3, which is 9. Pi times 9. So pi times 9 gives us 28.27. So now we're going to do the volume. The volume is the area of the base, which is 28.27 times the height. So we have 300 as our height. So if you were to think about this, I would have a pie, like a pie you eat, apple, cherry, pumpkin, chocolate, and I would make that into squares to serve. Really, usually we use triangles to serve, but I'm going to do squares. So in my pie, my first level of my pie that I can make I'll make it a pumpkin pie because I like pumpkin pie. I can serve 28.27 people. But I don't have just one pumpkin pie. I have 300 of them. So how many can I fit in? How many can I serve with 300 pumpkin pies? Well, we have 28.27. That's how many I can do for one. So we multiply that by 300, and that gives us 8,482.30, and that would be centimeters cubed. So if we go back to our office example, we have in here that we have a total number of office examples right here, 270,000 office rooms in this building. And then if we take a look at this whole cylinder that we have in the middle, and we say that that is our elevator, in that elevator, where we need to put the elevator in our building, that takes up 8,482 of those office buildings. So the total volume is 270,000 minus 8,482.3, and that gives us 261,517.70 centimeters cubed. We subtract because they're inside each other. That elevator takes up space where we would have had office spaces, but we need a way to get all the way up to the top if we were to use our office building analogy. Okay, that's still a pretty big building. So this is the volume of composite figures. So taking a look at this one here, we have on the bottom, well, it tells us that we need volume. So we have two figures, and the bottom one right here, this one right here, I'll use a different color. This one right here is a cylinder. Now I know it's a cylinder because it has a circle at the top. If it didn't have a circle, it would be a rectangle. So the volume of a cylinder is always the area of the base times the height. The area of the base times the height. So the base on here is the same on the top and the bottom, and it is a circle. So the area of the base is pi r squared. So the radius in here is from the center of the circle out. From the center of the circle out. So that, wherever the center of our circle is. Now this is up in the air, but you can see if you bring it down, it's the same here. And really, if we put it over here, it's 8, here, here, because the center of the circle all the way out is always the same. So our radius is 8. So we put this in our answer. We have pi times 8 squared, which is pi times 64. So that, times 64 gives us 201.06. 201.06 inches squared. So our volume is going to be The area of the base, which we just found, was 201.06 times the height. The height is always how tall it is. This is like we're having circle upon circle upon circle. So I have one circle that has 201.06, and then the next one, and then the next one. I'm going to multiply that by 7 because we have 7 high, 7 layers of 201.06 circles. Multiply that by 7, and that gives us 1407.43. So that's our volume in the bottom. That means that we're looking at how many cubes fit in here. So how many cubes fit into our cylinder? So on the top part that we have here, this part right here, this is a sphere. A sphere. So the sphere has a formula of 4/3 pi r cubed, and it's always the same. Now we have a half a sphere actually, so we're going to take our answer at the end and divide by 2. So 4/3 pi r. What is r? Well, r is the same as what we used over here. The radius is 8. We're still looking at the center of our, now our sphere out is always the same. So this is 8 cubed. So how do we put this in our calculator? 4 pi times 8 cubed. So what is 8 cubed? 8 times 8 times 8 is 512. We're going to take that answer. We're going to multiply 4 times pi times 512, and then we're going to take that answer and divide by 3. So 4 times pi times 512 is 6433.98. 6433.98. Now that's for a full sphere. So we have a half, so we have to take that and divide by 2. Take that answer and we divide it by 2, and we get 3216.99. 3216.99. So we're going to add those two together. They're one on top of the other. So the volume total is 1407.43 plus, that's our volume of our, that's the area, our volume of our cylinder, the bottom part, and then the area of the, the volume of the top is 3216.99. So we add those both together because they are not one inside the other. They're adjoined. So we have a total of 4624.42. And then because we're in, it says inches, we're inches cubed. Inches cubed. So that's how you find the volume of a composite figure.